Yep.
Okay, probability. First you need to know sample space. Sample space is a set of all things that can happen in an experiment. For example, if you toss one coin, the sample space is what could happen. It can land on heads or it can land on tails. And then again, you can have another example, 2 coins being tossed. The sample space could be it can land on heads, 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 tails, 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 heads. So 4 things can be happening.
All right, now you go.
Yes.
I'm talking.
Event is any subset of a sample space. Probability of an event is the number of ways an event can happen divided by the number of things in a sample space. For example, 1 coin lands on heads up. The event is it lands tails up. Sample space, it can land heads or tails. So that's 1/2. Another example is 2 coins land both heads up. The event is heads, heads. The sample space is heads, heads, tails, 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 head. So it's 1/4.
Things like that.
Okay, probability of a union. So the probability of A union B equals probability A plus the probability of B minus the probability of A and B. So an example, out of 52 cards, what is the probability that you will draw a heart or a face card? So the probability of drawing a heart is 13 out of 52. The probability of drawing a face card is 12 out of 52. And the probability of drawing a heart and face card is 3 out of 52. So you take 13 out of 52 plus 12 out of 52 minus 3 out of 52, which is 22 over 52, which is 0.423.
Computer. I'm just joking.
Okay, ready?
Yeah.
Oh, the probability of an independent event. The probability of A and B equals probability of A times the probability of C. And if you have more events, then you do probability of C, D, etc. So example, you toss a coin 3 times. What is the probability that it will land on heads all 3 times? So the probability it'll land on heads once is 1 out of 2 because it can land on tails. And then the probability that it'll land on heads twice, you do 1.5 times 1/2, which is 1/4. The probability of it landing on heads 3 times is 1/2, 1/2, 1/2, which is 1/8.
Come on.
Okay, so our first example problem is a pair of fair standard dice are rolled. What is the probability that the sum is 5? So, the sum of 5, you can have 1 plus 4, or 2 plus 3, or 4 plus 1, and 3 plus 2. So, that's 4 ways it can equal 5. And you have 2 pairs of dice, which have 6 sides. So 6 times 6 is 36. So that would be 4 over 36, which equals 1/9. And 1/9 is your answer. Okay, our next question is, a class is given a list of 20 study problems from which 10 will be a part of an upcoming exam. If a given probability that the
student will be able to answer. Oh God!
But the student will be able to answer A, all 10 questions. Okay, so A, you have the probability that a student can answer all 10 questions if the student knows 15. Okay, so the student has 15. 15.
Why did you straddle his arm, man?
Choose 10.
I know.
And then 20. Choose 15. And you divide those, which would be 21 over 1,292, which is equivalent to 0.016, which is the answer.
Okay, let's go back over.
Is this probability?
Yes, it is. I'm so glad you got that because I said probability.
We're totally still recording.
Oh, sorry. Stop.
Yeah.
So, what is the probability that the student will be able to answer B, exactly 8 questions on the exam? Okay, so you have 15, choose 8. over, wait, and then, well, you have to times that by 5, choose 2, because you have 8 plus 2 is 10, over 20, choose,
going on here, buddy?
They're recording for class.
over 10, which equals 225 over 646, which is equivalent to 0.348. Okay, C. What is the probability that the student will know at least 9 questions on the exam? C. I can't write like this. Okay. So the student knows 15. Choose 9, and then you have to times that by 5 and choose 2, because 9 plus, choose 1, because 9 plus 1 is 10. Over 20, choose 10. Now you have to add 15, choose 10, because it says at least 9. And then you have to do that over 20, choose 10, which is 49 over 323, which is equivalent to 0.152, and that is your answer. Okay, our last and final question is, in a room full of 30 people, what is the probability that at least 2 people have the same birthday? Assume birthdays are uniformly distributed and there is no leap year. Okay, this is a little bit more complicated and time consuming, so I'm going to skip a couple steps. So to know, first, I thought it'd be easier to figure out what are the probabilities that they have different birthdays. So you have 365 days out of the year divided by 365 possibilities that someone has that birthday. And then you would multiply that by 364 because somebody already has one birthday, and 1 minus 365 is 364. You divide that by 365 and you keep going on and on and on and on and on until you get to 335 over 365 because we have 30 people. Okay, so this all equals, after subtracting 1 and multiplying, it all equals a 0.269, which I equaled out to be a 27% chance that at least 2 people won't have the same birthday. I spelled birthday wrong. Yeah, B-Day. So then you take, what's 100 minus 27? It equals 73. So 73% chance that at least 2 people will have the same B-Day. And that's your answer.
Counting is finding the number of possible outcomes in a given situation, pretty much. So, like if you had 8 pieces of paper in a box, you're trying to choose 3 without replacing them. You'd have 8. And then because you took away 1, you'd have 7. Then you take away 1, you'd have 6. So you'd have 336. And say you didn't care about the replacement thing, and how many different ways could you spell a 3-letter word? If you can reuse letters, you have, there's permutations, order matters. You find the number of permutations of 8 horses taking 3 at a time, pretty much 8p3, and then that would equal like 336. And there's some ridiculous math that's involved. Combinations pretty much mean order doesn't matter. So if you find the number of combinations of 5 cards taking 3 at a time, be like 5 choose 3 would equal 10. Some more ridiculous math. Alright, so like how many ways can you get a 10 high face card if aces are high? And one card must be a 10, and the 4 must be less than 10. They can't be consecutive in value because that would be a straight. And it can't be the same suit, that'd be a flush, so you have 8 choices. So there's 8 choose 4 ways of picking 4 less than 10. But you must subtract 1 because once again you don't want the straight because they can't be consecutive in order. So you can't have like, 6, 7, 8, 9 and then the 10. And then now with your suits, you have 4 suits for each. So you have 4 suits times 5 possibilities. And once again, we must subtract 4 due to we don't want to flush. Let's subtract 4 suits because we're not going to use one of those numbers. So you'd have 8 choose 4 minus 1 times 4 to the 5th minus 4. The answer would be 70,380